And then the roots of a quadratic equation are just the solutions. So you guys might have heard me use the word roots or root a couple times, so nothing real like I would have pointed out over and over again. But here we are kind of using that word more directly. So the solutions to a quadratic equation are its roots. And then zeros are the x-intercepts. Again, this would be a phrase that you guys might have heard me use once or twice, but here we're going to start using it more deliberately. And here, I'm saying x-intercepts of a function. I guess not necessarily a quadratic equation. I should have said function there. Sorry, but in this case, it's quadratic equation. So, what's going to be kind of a bigger deal is that if roots are the same things as solutions and zeros are the same things as x-intercepts. Actually, I guess why are they called zeros? Because what we're looking at here, when we talk about x-intercepts, that's when y is equal to 0. Okay, so we say, what are the zeros? Really, it's asking us what values of x make y 0. Right? So what are the ones that give us 0 or make y 0? That's why they're called zeros. Okay. So if roots are the same things as solutions, and zeros are the same things as x-intercepts, well, it turns out x-intercepts are the same things as solutions, and thus zeros are also the same things as solutions. So kind of a bigger deal here is that solutions and x-intercepts and zeros and roots all really mean the same thing. So this is going to be something I'm going to be kind of pushing you guys on over here over the next couple of weeks, just to recognize this, that these four terms, these four words, really mean the same thing. So you're going to keep hearing me ask you, what are those four things that all mean the same thing? Or what are the other three things that we can call a solution? Okay. And we want you guys to kind of know this, because what's going to happen is that we're going to be asking you guys questions like, hey, solve this, right? Well, we've been solving equations for a long time. Well, then it's going to change in that to say, hey, find the roots of this, or hey, find the x-intercepts, or hey, find the zeros. And then to realize that that's all really the same question. That if you can find the solutions, that means you can also find the roots, you can also find the x-intercepts, you can also find the zeros. And so we want you guys to be able to read the questions and understand that it's not four different questions, it's really just one question. Okay? So I want you guys to start getting those four terms, those four words kind of down to knowing that they mean the same thing. Okay? So thinking about what roots are, or what zeros are, if zeros are x-intercepts, right? And if we want to think about what would a quadratic equation with two zeros look like, or what would a quadratic equation with 1 0 look like when we graph it? Okay, so of course it's a quadratic equation, so that means we're talking about a parabola, right? And if we're talking about a parabola with two zeros, right? Two x-intercepts. So what would a parabola with two x-intercepts look like? Well, that means it has to cross the x-axis twice. Right? So that one has two zeros. Right? Well, what if it only had 1 0? What would that look like? What if it only had one x-intercept? Right? What would that look like? So for it to only have one x-intercept, that means it would have to go down to the x-axis and then bounce off. It can't cross it, it can only touch it. So it actually just hit the x-axis once. Okay? Then it would bounce back up. Okay? And then what if it had no zeros? What would that look like? So no x-intercepts. So this graph can't cross the x-axis. What would that look like? Okay. This is something we've actually talked about before. Way back when we first learned vertex form, we talked about how to find the x and y intercepts for those problems. And that was, involved you guys having to square root, and that's where we talked about the pluses and minuses. But there were some of the problems where you ended up trying to square root like a negative number. And it came down to you doing that, right? And we can't square root negatives. So there was one problem we did in the notes like this, and there was one problem that we did in the homework like that, but we haven't really talked about it much. What it came down to is we can't square root negatives, and then I told you guys that meant there was no x-intercepts for that problem. So we haven't talked about it a lot. We're going to get to talking about that more, what that means, why that happens. But there are some problems that don't have any zeros, right? And so thus, if we have two zeros, that means there's also two solutions, right? If there's one zero, that means there's one solution. If there's no zeros, that means there's no solutions. So solving these equations, what are your options, right? Could have two answers, could have one answer, or could have no answers, right? I can't ever have three, can't have infinite, okay? Those are the only options. Of course, all of these could be turned upside down. Right? There's nothing stopping me from doing that. So it could have two answers and look like that. Could have one answer and look like that. Or it could have no answers and look like that. Right? So they could all be turned upside down. Nothing stopping us from doing that. Okay? So kind of getting a visual for what we're about to do here. Right? When we go and find these zeros, go find these solutions, what would that look like visually, graphically? Okay? Anything here? Want me to go back over real quick? How you feel about that, Ty? How you feel about that, Amaya? Connor, how's it feel? Good. All right, good, Jasmine. Thank you. Okay. All right, so before you write anything down, I want to show you guys a couple things real quick. So we're going to go into solving a quadratic equation, solve the equation, solve the equation. Then the directions are going to change. Okay? Find the zeros of the function by writing an intercept form. It's going to be the same thing with your homework. It's going to say different directions. Again, the whole idea here is that this process for this problem is really no different than the process for the other problems. Okay? That finding intercepts or finding zeros or finding solutions is really the same thing. Okay? So changing the directions isn't going to change our process. All right, so here's our first equation we're going to go through. Okay. So we want to solve this quadratic equation, right? Which again means we want to find its x-intercepts, we want to find its roots, we want to find its zeros. Okay. But really we want to find out what x is equal to. Okay. Well, normally, I don't want you guys to write this part down. Normally when we solve, we would say, well, let's get x by itself, right? That would be our goal. Okay. Well, if I try to get x by itself here, the first thing I would do would maybe add 42 to both sides, right? And so that would leave me with x squared minus x equals 42. But with the x squared and the x, I can't do anything. I can't combine those, right? There's no way for me to combine those into one x. And if there's multiple types of x's, I can't get x by itself then. There's nowhere for me to go here, okay? And so our old method of solving doesn't work. We can't get x by itself because there's too many different types of x's. Okay? So when I say types, I mean x squareds and x's, or if there was x cubed or something like that, right? There's too many types of x's. We can't get it by itself. So we have to have a new tool. Okay? And so just like we've been talking about, with factoring, that when our one method stops working, we need a new method. Well, that's kind of what it's going to come down to. Is we need a new way of solving for this. Okay? It's going to be quite different than any way we've solved in the past. And what this is going to come down to is something called the product, or the zero product property. And you don't necessarily need to write this down if you don't want to, but you might want to. So this is going to come down to the zero product property. Okay. And really simply, what the zero product property says is if A times B equals 0, so some number times some other number equals 0, then either A equals 0 or B equals 0. Right, that makes sense? If A times B equals 0, then either A or B has to be equal to 0. That's the only way to get 0 out of a product is for one of the numbers to be 0. Okay? So where this is going to fit in with factoring, right? What's factoring? It's about figuring out what multiplied to be what we have, right? What multiplies together to get us x squared minus x minus 42, right? And that we're going to end up at this, right? Something times something else, x, some number times some other number equals 0. Well, either this number here, whatever it is, would have to equal 0, or this number it is, whatever it is, would have to equal 0. And then that would give us our values for x. So that's where we're headed with this, is that we can find out how to get just one x here. And then we'll figure out that what's the value that's going to make that 0, and what's the other value that's going to make this one 0. Okay, so that's where we're headed with this, how the zero product property helps us figure that out. Okay, so factoring is going to get us there. Okay. So we think about how do we factor, right? And so what's our type of factoring that we always start with? What type of factoring do we always start with? All right, Brooklyn, GCF, okay? So Brooklyn, do these terms have anything in common? Yeah, no, right? So no GCF, okay? Well, then from there we went to, how many terms there were, right? 4 terms meant we could do grouping, and then 3 meant, or 2 sometimes, meant we could do AC method. Okay, but we got 3 terms, so we're going to go in that AC method. So since we can't, no GCF, that means we're going to go to AC. Well, what is our A? What is our B? Again, you guys don't need to write these down if you're past that already, but if it helps you to write them down, then do that. What's our AC, right? Well, of course, A times C is just 1 times negative 42, so that's easy. That's negative 42, and we need that to add to negative 1. All right, so what are the factors of A times C that add to be B? All right? And some of you guys might look at that and go, oh, I know them right now. And if you do know them, then you get to move on. If you don't know them, what do you do? All right, what are the numbers that multiply to be 42 and add to be 1? Okay, so you start, what's 1 times what is 42? What's 1 times 42? Okay, 2 times what? All right, so what's 42 divided by 2? That's 21. What's 42 divided by 3? That's 14. All right, what's 42 divided by 4? So if we do that, we don't get a whole number, so that one doesn't go in. All right, 42 divided by 5. 5 does not go into 42. 42 divided by 6 is 7. And then we can stop because 7 is the next number I want to write down. But I already wrote down 7, so we're done. Those are all the factors of 42. Now, right, notice how I wasn't saying negative 42 ever. I was just saying 42. Now I go back and say, but I need a negative 42. All right? So one of those numbers needs to be negative, and I need to add negative 1. So negative 6 and negative 7 and positive 6 will get us there. Okay? So we rewrite the problem. So we bring our x squared down. But now I have plus 6x and minus 7x. So make sure you're putting those x's on those numbers. And then the minus 42. And that's still equal to 0. Don't drop your equal sign off. Okay? So we took the negative x and we broke it apart in a very special way, a unique way. Okay? And then we break it in half. And we ask ourselves what's common in those first two. Those both have an x in them. X times what is x squared? What's x times x? X times what is positive 6x? So positive 6. And then I look at the second two. Right? First term is negative, so I take out a negative. Okay? 7 does go into 42, right? We just know that 6 times 7 is 42. So we take out a negative 7. Negative 7 times positive x, and negative 7 times positive 6 still equals 0. Remember, there's a built-in check right here. Is it going well? If these two terms are the same, you're doing all right. Don't force them to be the same. It's supposed to work on its own. Right? It's supposed to talk to you and let you know that you're doing things right. So those things that are the same come together, and then our leftovers come together. Right? The x and the minus 7 go together. And it's still equal to 0. Okay. So what we had been doing, adding, right? If I was just asking you guys to factor, we'd be done factoring, right? But here we're solving, so there's one new step. Okay. So this is where the zero product property comes in. This whole thing times this whole thing equals 0. That means this number, right? This x plus 6 is just some number times this other number, x minus 7 is just some other number. One of those has to be equal to 0. Okay? Oops. So which values of x will make them 0? And so what we do with that, take x plus 6 and we set it equal to 0. We take x minus 7 and we set it equal to 0. And the question we're asking here is, what plus 6 is 0? Right? And usually the most common answer people to shoot off is 0. Right? What's x equal to? Oh, is x equal to 0? No, because 0 plus 6 doesn't equal 0. Okay? What would x need to be in order to make this 0? Right? So if we subtract 6 over, so x would equal negative 6. Right? Here we say x minus 7 is equal to 0. Well, what minus 7 is 0? Well, 7 minus 7 is 0. So there are our solutions. Now we're done. So there's one new step, right? So setting each factor equal to 0 is kind of the new step here. The rest of it was just factoring. So once you're done factoring, then you set each factor equal to 0, solve those simple equations, and then those are your answers to the problem. I want to show you that it actually works. I'm just going to use one of them. I'm just going to use the easier one since it's positive. All right, so I'm going to take 7 and I'm going to plug it in. All right, 7 squared is 49. 49 minus 7 is 42. 42 minus 42 would be 0. So we see that plugging 7 in does work. Plug in negative 6 in would also work. Okay, so just seeing how it does actually solve the equation. The other side of things, right, what were we talking about? Solutions are the same things as x-intercepts. What would this graph look like if we did graph it? Okay, you guys don't need to do this, we don't want to. But it's kind of just that visual idea of what are we actually finding here. Okay, so way out here at negative 6, we'd have an x-intercept. Way out here at 7, we'd have an x-intercept. What's this number right here? What does that represent? Y-intercept, right, Camden? All right, so there's our y-intercept way down here at negative 42, right? So this graph would look something like that. It would actually turn just a little bit to the right of that. Oops. So that's really horrible parabola, but okay. It will look something like that. So just visually, like, what are we up to here? All right, we found the x-intercepts. We already knew the y-intercept. We could graph it. It would be a huge graph to draw. Okay, that's what we've been up to. Okay, finding those x-intercepts. Okay, I'm gonna practice this some more. There's really nothing else that I need to teach you guys. This is the process for doing this. We're just going to practice different problems. Okay, finding solutions, finding x-intercepts, finding roots is just like this for quadratic equations. Okay. Is there anything particular you want me to highlight or go back over before I go on to the next problem? Clover, how you doing? Lucas, how you doing? Hope, how you doing? Okay. All right. Let's solve this equation. So we're going to find the zeros, we're going to find the x-intercepts. Okay, it's already equal to 0. And there's multiple types of n's here, so I can't get n by itself. So the n squareds and the n's. So we can look at our factoring first. So is there a GCF? There's something we can take out of both? Any more than that, Lily? There you go, Lily. So yeah, we got GCF, right? 5n. So let's do that. 5 times what is 45? Nine n, right? Need that extra n. Of course, 5 times 2 is 10. Okay. So we've done GCF factoring. So we should be asking ourselves, is there more to factor? Right? So there's 2 questions we need to answer about this. Do these 2 things have anything in common? Camden's saying no. Okay. Is there any squares or cubes or any higher exponents in here? Okay. Both those answers are no. So that means we're done factoring. Man, that was easy. So once the factoring is done, the next step, right, the new step, set each factor equal to 0. So 5n equals 0. 9n plus 2 equals 0. Then we just solve each of those equations. So again, you look at that 5 times what is 0. Of course, it has to be 0, right? But what we really are doing is dividing by 5. But n equals 0. A little bit more to do on this one. So minus 2 on both sides. That's just a 2-step equation. You guys have done those so many times. Divided by 9. So I do want you guys to leave your answers as reduced fractions, not decimals. Okay, there you go. That's it. Those GCF factoring problems, super easy. Anything about that one? You guys want a question? Anybody need more time there? Tatum, does that make sense? Zach, that makes sense? Dawson, make sense? All right, let's look at another one together. So there's something fundamentally different about this problem than the last 2 that we've done. What's different about this problem? Okay. 28's on, so Cam is saying 28's on the other side instead of what? Instead of 0, right? So Cam is noticing that there's no 0, right? It's not equal to 0. So remember what we're after here, right? We're after the solving, which is the same thing as being after the zeros, which means that the y value has to be 0, right? Well, where would y be, right? It'd be y equals this, right? Or the y could be over here. So that has to be equal to 0. Can't be equal to 28, okay? And so for us to solve this, we have to get one side to be 0 first, right? And so again, what's very different about these problems in solving in the past is that there are multiple types of x's. We can't get x by itself. So oddly, we move stuff towards the x rather than away from it. So that 28 has to move over first. So our real problem is actually x squared plus 3x minus 28 equals 0. Okay. So if one side is not 0, you need to get it to be 0 before you can do anything else. Okay? So first step. Then we go into our factoring methods. Dawson, is there a GCF here? Or Jacob, is there a GCF here?
No.
No? Okay. So that means we go into what? No GCF, so we're going to do what? Over, Brooklyn, what's our next method? Jet, what's our next method? AC, Lily, all right? So what's our AC? Okay. Of course, our A is 1, our C is negative 28. So A times C is negative 28. That needs to add to 3. Again, if you see them, if you know the factors of negative 28 that add to be 3, great, you get to move on. If you don't, what do? Okay. 1 times 28, 2 times 14, 3 does not go into 28 evenly, 4 goes in 7 times, 5 does not go into 28, 6 does not go into 28. We already have 7 down, so we're done. We need negative 28 and positive 3, which is going to come from negative 4 and positive 7. So x squared minus 4x plus 7x. Again, make sure you put those x's there. Minus 28 equals 0. Don't drop off the equal 0. Okay. Break it in half. It's x times x minus 4. So it's positive this time. Okay, so make sure you're writing a plus 7. If you're not putting those plus signs there, you are going to lose points. And it needs to be there. 7 times x and 7 times negative 4. And it's not your job to force those to be the same. It's your job to check to see if they are the same. And if they're not, that means you're doing something wrong. So the x minus 4s go together. And then the leftovers, the x and the plus 7 go together. Still equal to 0. Don't lose that. Okay. And that last step, right, set each one of those equal to 0. What would x have to be in order to make this 0? Right? Easy equation to solve. Hopefully you're kind of seeing the pattern here, how to solve these quickly, and then you start doing it in your head. Okay? When you guys can start doing some of the stuff in your head, I'm great with that. Okay? You don't need to, again, if you can do this in your head, that's awesome. You can go straight from asking yourself that question to writing in the equation. That's great. You can go straight from looking at this to the answers. That's great. These are easy enough to do in your head that I'm not expecting you guys to have to do work for that all the time. Okay? But I am expecting to see steps here in the factoring. Okay? There's a couple things you can start taking shortcuts on. So hopefully you just notice that the sign needs to change there. Okay? There's our x-intercepts. There's our solutions. There's our roots. There's our zeros. Okay? Anything weird there? Jet, how you feeling about that? Peyton, how you feeling about that? Avery?
Good.
Jet, I saw you in the paper. Good. There's good. If you knew you were in paper. It's good. All right. So new set of instructions. Okay. What I really want to make sure you guys understand is that it's no different in regards to the process. Okay. So I would write the instructions out this time so you guys can just see them. And there is going to be problem just like this in the homework as far as wording goes. Okay. So I'd write that down so that you just get it in your head that you're not really doing anything different. Okay. But here we're after finding zeros. Okay. Notice how it also mentions writing an intercept form, right? There's something we've talked about before, right? That was, y equals a times x minus p times x minus q, right? But how do we get into intercept form from standard form, right? There's our factoring, right? That got parentheses again, right? So there's our factoring, right? It's no different. But what's it mean to be a zero, right? It means that x is something, but y is zero, right? Well, where's y here, right? Well, y is this. That whole thing is zero, right? What we're not saying is don't make x zero, don't plug in zero, right? We're making this whole left side equal to zero. So in order to solve, one side has to be zero, right? Just like we said on the last one. Because finding zeros and finding solutions is the same process. So getting that equal to zero first, and then looking for our GCF. 9 and 24 both have 3 in them, but 16 doesn't have a 3 in it. 16 and 24 both have a 4 in them, but 4 doesn't go into 9, right? So there's no GCF. So then we're going to our AC method. Well, our A is 9, our C is 16. 9 times 16 is 144. Kind of a big number there. But we need 144 to add to be negative 24. So we could be at this for a while writing out all our factors of 144 because it's a pretty big number. But 144 is also a special number. What's special about 144? It's a perfect square, right on, Camden? What's our perfect square here? 12. So Camden recognized 144 as being a perfect square. Okay? And that is something that's going to be important for you guys to start knowing. I think it's something we're going to talk about a little bit more tomorrow as we're doing what we're doing, that you guys really should know what 1 squared is all the way down to 15 squared. Okay? That knowing what those are equal to will really help you do a lot of the stuff that we're doing much faster. Okay? And it's going to be the same way with your cubes. 1 cubed all the way down to 10 cubed. That I would ask you guys to start recognizing those numbers. And so basically what that's going to come down to is a little bit of studying. Okay? You write them down and then you just keep looking at them, or you keep writing them down. Right? What's 7 cubed? Write it down. What's 7 cubed? Write it down. Write it down. I had a teacher in college that said if you write something down 17 times, you'll know it. Okay? As he was like trying to get us to like memorize formulas and stuff for some of the engineering stuff we were doing. He's like, write it down 17 times, you'll know it. I don't know where he got the number 17. I can't remember anymore, but that was just his thing. He was a really smart guy, so I trusted. Okay? So just getting those numbers recognized. Okay? We've written all the way down to 12, right? Think how long that list would have been if we had to do that. Okay, it would have been a pain in the butt. Of course, we need negative 12 and negative 12 to get negative 24. So 0 equals 9x squared minus 12x plus 16. Break it. 9x and 12x, right? Both have 3.
Only one of those 12s be negative, not both.
What's a negative times a negative, Peyton?
Positive.
Right? And what's
But doesn't
negative 12?
it?
What's negative 12 plus negative 12?
Oh, it's plus. Never mind.
Yeah. We're always adding right? Sum of these two numbers. Right? Thanks for asking, though. So 3x times 3x would give us 9x squared. And 3x times negative 4 would give us negative 12x. This is negative, so make sure you take out a negative. 4 goes into 12 and 16, so negative 4 times positive 3x. Negative 4 times negative 4. Still equal to 0. I usually like to have my 0 on the right side, but it doesn't matter if you put it on the right or the left. Remember those things inside the parentheses are supposed to be the same? They are. I'm doing good. Those things outside the parentheses, we bring those together. Still equal to 0. You guys have seen this before where it's the same binomial times itself, right? We could write that as 3x minus 4 squared. I'm not going to because that's not what we're up to, right? We're not factoring this. That's not your goal. Your goal is to solve this, okay? And the next step in that process is to set those factors equal to 0, okay? So writing it as a square is not going to help me. So I'm just not going to do it. Okay. So 3x minus 4 equals 0. I'm gonna add 4 to both sides. And there'll be some of you guys that start doing these in your head. That's perfectly fine. It'd be great if you can start doing those in your head. Okay, so add 4, divide by 3, divide by 3. And you guys have solved two-step equations so many times, should start getting to be pretty easy. So x equals 4/3. Do I need to solve this equation? Do I need to solve this? What you think, Camden? Yeah, Claire's saying no. Okay, of course not. Right? Why would I solve the same equation twice? It's not like it's going to give me a different answer. Okay. And so there's our solutions, but there's only one solution, right? It had 2 answers, but the same number. So it's not unique. Okay. So again, visually, if we wanted to, we could think about what that would look like. Up here at 16, it would cross the y-axis. But here at 4/3, which is between 1 and 2, that's where it hit the x-axis, right? And that's just going to be a bounce. So this is something that's going to come up later on in the year. We don't think we'll get to it this year or this semester, but it'll something we'll talk about next semester. I don't know how it's going to work as far as teachers. I know they've been trying to push it more where you have the same teacher both semesters, but I don't think they've gotten it that way yet. So that's called a double root. So it's something we'll talk about next semester, but it's the same number twice, right? Same answer twice. So it's called a double root, right? A root is the same thing as a solution. I just want to kind of throw that out there to kind of plant that seed for you guys. Okay? So here's what it looks like when you get the same answer twice. Okay. Anything here you guys want to talk about? I'm gonna give you guys a couple that I want you to try on your own. And I'm probably gonna give you about 7 minutes to do that because there's one other quick problem I want to show you guys before class ends. So I'll give you about 7 minutes to go ahead and try those two. I'll put the answers up in a minute. All right, here's what you guys should have gotten. No, because 3 doesn't go into 14, Connor. Not sure what happened to your X there in the middle there. Do you see where you made a mistake, Connor? Okay. Which one, Clover? Which one? First one, second one? Oh, the first one? Okay. I mean, did you get this part, Clover? Just moving everything over? All right. So A times C was negative 72. And I need negative 72 to add to be 14. And so just going through, 4 times 18 is 72. And then negative 4 plus 18 would be 14. So that's how I would get the negative 72 and the positive 14. You good there, Clever? And then those numbers went there, and then I just did the grouping from there. And then again, I just set that equal to 0. I get this. I set this equal to 0. I get that. Again, notice how short that GCF problem was, right? When it's those 2-term problems, okay, like that. All right, so there's one more I want to show you guys real quick. And I know we're really close to the end of class, so I want to show you guys this. Okay? So finding zeros, right? Finding solutions, finding x-intercepts. Right? First thing we do is set one side to be 0. This is a method we're going to talk more about tomorrow, but it's a faster method of AC method. It's very pattern based. Okay, so if we thought about the AC method here, A would be 25, B would be 0, and C would be negative 64. And if I go and do AC, A times C is going to be negative 1600. Okay, that's a huge number for us to try to factor out, right? List out all the factors of 1600. Right? Not going to happen very quickly. So instead, this is what's called a difference of squares factoring, a difference of two squares factoring. And oddly enough, I've seen some of you guys doing this on homework. Not quite sure where you picked it up, but okay, it's a special type of AC method. But it's going to be our fourth tool in our toolbox that we're going to learn tomorrow, or go back over tomorrow later on. So what it depends on is that this is a perfect square and that this is a perfect square. 25x squared is a perfect square and 64 is a perfect square. So what we do is we write two sets of parentheses. One's going to have a plus, one's going to have a minus, because that's how we get a negative. Right? The only way to get a negative is to have a positive and a negative. Then I ask myself, what times itself is 25x squared? Right? 5x times 5x. What times itself is 64? 8 times 8. And I'm done factoring. Okay. That's it. But it's based on those have to be perfect squares, and that has to be a subtraction. It doesn't work if that's not a subtraction. And then from there, we would finish it by doing this. I'm not going to do it. You would set that equal to 0. You would set that equal to 0. And you would solve. And you do need to solve both because they're different. Okay? But it's just another method. Okay? We're going to talk more about it tomorrow. We're also going to talk about sums and differences of cubes tomorrow. And those will be our last 2/3 methods that we're going to learn for factoring. So